In the game NSAIntern, you play as an intern for the National Safety Agency who can break into the phones of unsuspecting individuals, citizens of the USA, but perhaps they're terrorists. And the crux of the game is you can break into the apps, like here's the Photos app, and you can look at this alien photo and you could say, oh, that might be suspicious. Or you can go into their notes and you could see that, oh, they're looking up some information about different rifles. That might be suspicious. But if you think you found something that you want to include in the evidence, something that you want to submit with your decision of if they're a terrorist, you can drag with your finger, you can grab the briefcase over here, drag it onto the item, and then the app will actually take a context-sensitive photo of whatever the piece of evidence is that you're trying to grab. Okay, so to determine what evidence you're looking at, there's a raycast that shoots right out from under the briefcase, but we're going to be going over the technical implementation of this system because it's not easy. There's a lot of tricks that go on behind the work here. And it was a significant technical challenge for me on this project. One which has haunted me the whole way because I had this bug I wasn't able to solve until recently. But I did, and I had a question on one of my recent videos, how do you take screenshots in Unity? How did you do that? And I'm happy to explain it now. I would love to give you the code in some way, but unfortunately it's pretty integrated within a larger system, so there's a lot of helper methods. I question how useful that would be. So instead I'm just going to explain the methodology if you're interested in doing something like this in your own project. But before I go further, I just want to address that Unity does have a screenCapture.capture screenshot method. And this may be the perfect method for you. I would say if there is an option to go the easy way, then almost always you should. And what this will do is take a screenshot of the entire screen that the user is seeing. And it is cross-platform, right? So this will work on Android, iOS, whatever. However, that is not what I wanted. If there were multiple notes here, I wanted the user to be able to drag the briefcase onto just the note that says plumber 4 p.m. and then just that would be submitted as evidence. So that's very different than capturing the whole screen. And if I capture the whole screen here, it wouldn't be clear to the user which piece of evidence they were going for. So there's a lot more going on under the hood for this implementation. However, if the easy way works for you, then just go with that method. So without further ado, we're going to talk about how I did it, what my process was. And the crux of the issue is that, well, let's think about the easy case. Let's say we were taking just Unity's baseline method, a screen capture of the entire screen. Well, the bounds of that image are pretty well defined, right? It's just however many pixels are on the screen, those are the ones you want to capture. And the bounds are literally the same bounds of the game. However, what I ran into an issue on this project is, let's take this note, for example, where we've got some descriptors, fat, acne scars, stuff like that. You can drag it above the screen, okay? And what's going on here, if I were to open up the scene view, is it's going beyond the bounds that the user can actually see. So the user can't see above notes, okay? It's not rendered. And I can drag the note so that it comes up above here, right? So you can see that fat and acne scars are no longer part of the screen. And the issue that arises here is that even if I can get you the dimensions of the note, this yellow note, it would extend beyond the dimensions of the phone. And so if you try to take a screen capture or render a texture that is not currently being rendered, it's not within the bounds of the screen, you're going to have a big problem, right? And so just to illustrate this a little more cleanly, I have a note, I have a paint option here. So the bounds of the, let's open this up here. So the bounds of the phone are something like this, okay? It's drawn in red. The bounds of the note, I'm going to draw in blue, okay? They look something like this. The problem is they don't 100% overlap, right? What we need to do is create a different rectangle, which I use the green one here, and that's actually what we want to capture as the image, okay? And so finding that green rectangle and getting the math just right for that took me a very long time. And I'm going to share with you all the work, well, not the work, but I'll share with you the fruits of my labor so that if you want to do something like that, hopefully you can in half the time or sooner. Okay, so let's jump into it. I'm going to go into the code now, and we're going to start from the very beginning. So let's see. So I have a method here called add screen capture to evidence, but let's just see who's calling this method. I'm going to walk all the way up. So what's going on here? So this is examine evidence for collection. So we're still a little bit too far in. Let's go one level higher. Okay, so these are handling the raycasts. So you can see it's at this point we're already raycasting from NSA evidence briefcase. So this is the stage in which we are dragging the briefcase, we drop it, and we raycast to determine whether or not we're looking at a piece of evidence. It could be the case that we're not, for example, right here. Or, okay, that was a bad example. Here, I'll do one over here. You could drop it right here. I'm not pointing at a piece of evidence. This is just the background for the phone, so it's just going to go back to where it came. On the notes page, everything's a piece of evidence. So what you want to do at that point is do a raycast to check the object and check if it's a piece of evidence. And the way that I do that is I have all of the notes tagged with the layer evidence. So basically, I'm just checking what layer it's on. And if it is on the layer evidence, then hey, we're going to send in that game object for review. And that's essentially what's happening here with hits. And so then we do some processing on that game object to determine whether or not we want to collect it. So there are some basic checks here. For example, is the briefcase full? Have they already collected all the evidence they need to? Is the evidence an app icon? So for example, I believe you can, if I try to collect the Photos app, it's just going to open up the Photos app. Okay, so there's a few edge cases like that you want to get just for the ergonomics of the app. But when we're driving down into the meat of it, which is that the evidence is not an app icon, thus a screen capture is required. Okay, and so what we're going to be creating here is essentially a struct, I believe. Or is this a class? Let me see. No, it's a struct. So we're going to be crafting the struct as we go along the path here. And it has a name, an image path, and a UGC description. So the name is, I think that is a important thing. This is sort of like an ID, a unique identifier, which is going to tell us what kind of evidence it is, which is useful later to determine what outcomes they get. The image path is going to tell us where we're saving it on the device. And then the UGC description is user-generated content description. That is when we take the screenshot, whatever the user types into here. That's our UGC. Push save, collect the evidence. Awesome. So what we're doing right now is we're just slowly crafting that struct. And I'm being explicit here in explaining that the image path is going to be filled in later. Right now it's just null. And then let's jump into add screen capture to evidence, then inspect method. Okay, so obviously there's probably a little bit too much going on in that method, given that name. But what it's going to do is it's going to save a PNG to somewhere within the player assets file. This looks like the path for a desktop computer, but on Android it uses some sort of generic path so that it'll be all kosher. And let's see what it's doing. And then it's going to actually open up the inspector with the image if it's successful. So what this is doing is it's taking the screen capture, and then if it's successful, it's going to open up the inspector, which is this screen, which is inspecting the evidence, essentially. So just to explain this briefly, the first thing we do is we move the briefcase away. So it's very important, or at least it was for me, that we don't have the briefcase in the screenshot. So what I do is I tried to set it to be not active, but what I found is that especially when you're dealing with several things in the same frame, Unity can be a little bit lazy with respect to destroying game objects, certainly, but also to just setting them as inactive and not rendered. So since I'm taking the screenshot this frame, I found that actually doesn't work for me. What I need to instead do, in addition to setting it active to false, which I think makes it clear what's going on here, I actually move the position to 1,000 to 1,000. So temporarily, I transport the briefcase somewhere really far away just so it doesn't get in the picture. And then later on, I use the position before the photo to bring the briefcase back. Okay, so we're going to be doing a coroutine here, which means we're sharing the main thread, and we're going to have some sort of like co-process working at the same time. And then we're going to actually call a callback. So then the remainder, all of this text right here, is what we're going to do after the screenshot is taken. So first we check if it was successful. Oh, well, first we bring the briefcase back, then we check if it's successful. And then what we finally do is destroy the clone for picture. And the clone for picture is not something I've addressed yet, so I'll explain it now. Since we're going to be, so we have originally the blue rectangle. We have the game object that we're trying to take a picture of. What I do is I actually scale that game object down so that the rect transform is only covering the green rectangle, which is exactly what I want, and then I take the photo. This is a problem though, because if I scale the game object, the user's going to see it. It's going to look weird now that it's scaled in the game. So in order to ameliorate that issue, I've created a clone of the game object. So essentially I take the blue rectangle, I clone it so that there's a second blue rectangle, and then I turn that second blue rectangle green. So essentially I have one picture, I have the object, I clone the object, I squish it, take the photo, delete the squished object. That's the secret. And that's how I do it. So what I have to do is actually grab a clone, and I believe that's what's going to be passed in here. So the final bookkeeping is just to destroy that clone. The meat of this method happens within restrict bounds to viewable bounds. So it starts with me taking a rect transform, which is supposed to represent the photo bounds, and it's going to go into this method, which is going to squish it down. It's also going to assign the clone, so we don't have the real object being squished. So let's jump into that now and explain that part. Okay, restrict bounds to viewable bounds. The main idea here, again, is for us to get the blue rectangle to be the green rectangle, right? We want, or in this, sorry, I don't know if this is very accurate, but I think I drew my red rectangle wrong. It should be like this. The red rectangle is here so that we don't get that note. We don't want that bar up there. Then we're going to have the green rectangle here, or sorry, the blue rectangle here. And then finally we'll have the green rectangle. Oh, what? We'll have the blue rectangle here. Okay. And then finally we'll have the green rectangle in between them all. Okay. So that's a more accurate depiction. Because I wanted to be clear that the green is right at the top of the red. There's no space there. The red rectangle, I could show you right now. I think it's called image bounds. Or bounds. Okay, so here's that rectangle right there. So this just scales with respect to the screen size and kind of hovers right around there, below the bar. So we don't have the notes header in every photo, which, you know, that wouldn't be nice. So to begin, what we do is we clone our original photo bounds. So we're taking photo bounds, we are cloning it, that way we could squish it, and we are parenting it to the same parent that photo bounds had. So here's a little note here describing to myself what's going on, and I'm saying, you know, I'm trying to take it in by value, but the method is still changing it, so I need to clone it and use that new guy's transform, affecting it, and then kill him. That way I don't change the original. I temporarily rename this object clone for picture. I think that's just for debug. And then what I do is I create a new rect transform, my photo bounds, which at the end of the day is going to take on our final dimensions. Okay, so now what I do is I remove some components from the object. I have some components on my game objects that specify what position it should be. So for example, my notes controller is going to make sure that this note is right above this note, and it looks nice when I'm scrolling. And so because it's controlling its position, well, that's terrible for me right now, right? Because I need it to stay in one place so I can take the damn screenshot. So I need to remove all these components to make sure it's not moving around while I'm trying to take my photo. Okay, the analogy is maybe when you're taking the family photo and you got the little kids who are running around like crazy. You gotta kill them so that they stay in one place, and then you just have their bodies, and it's a very nice photo. But okay, it doesn't matter. The point is, we go to clone for picture here, which is going to be the transform of our clone. And then we're going to assign the bounds and the photo rect. So these two rectangles, rectangles, are quite literally, photo is red. Those are, bounds is red. Those are the bounds. And then the photo is blue. That's what we want to take a photo of. So we need to get the photo blue bounds to agree with the bounds. Sorry, we need to get the photo blue rect to agree with the bounds red rect in order to get the green. Okay, I think you get the picture. In order to make things simple, all I'm doing here is evaluating whether or not the note is too high or low. In your code, you might need to do a little extra checking to check whether or not it's too far to the left or the right. But for me, it was pretty simple because all my displays only scroll up and down, so I didn't need to worry about that. And so it was a simple check of whether or not it was above bounds, below bounds, both, or neither. And we'll talk about all those cases in just a second. The other thing I want to address is I wanted to grab explicitly the top of the photo and the bottom of the photo. This could be a little bit hard to think about with Unity's UI system, so I'll be explicit here. The photo.xy, those positions you would normally grab, are the center of the transform. So what you need to do is you need to go to the center and add half of the height. The problem is if you just grab photo.height, it's not going to be scaled, which is why there's an extra step here that makes sure to scale the height by the photobounds.lossyscale.y. Okay, so that's a very important step that I didn't understand, and to be honest, it's still a little Byzantine, but it's very important that you're scaling with the right portions. Just to explain that visually, Unity has two ways to measure the height. There's the literal height right here, okay, which is it's top and bottom here. But then there's also a Y scale. So if you change this Y scale to 2, you notice that it just became taller, right? So I changed the height, but I didn't change the height here, right? So it's almost like the height could be changed in two places: the scale and the actual height. So you need to look at both, okay? And so that's why we need to take the scaled height. So we're accounting for those two different parameters, the scale and the height itself. And to do so, you just get the scaled height, which is height times itself, or height multiplied or scaled by the local scale, the lossy scale, excuse me. So after you've done all that hard work, you now know whether or not it's above bounds or below bounds, neither or both. So if it's above and below bounds, okay, so in that case, we would have basically a blue rectangle that is taller than the red rectangle. Well, in that case, we just take the red rectangle. If it's literally covering the entire screen, just take a photo of the entire screen. That's the idea there. So in that case, we just return photo capture bounds. Another edge case here is if it's not above or below. So if our blue rectangle is instead already in the position that the green is, it's already in a nice location, then we don't have to worry about anything. Just take the photo. The fun part comes when it's above or below the bounds, okay? And in that case, what we want to do is chop off the amount we are above the bounds and shift downwards by half of that. In other words, we want to find like this. Oh, that's a little hard to see. We want to find this purple region. Can I color it in too? Is that possible? Does this come with fill? How do I do this? Fill. Solid color. Here we go. You want to take the purple region. You want to half it. Oh, sorry, no. You want to take the purple region and chop it off, okay? So basically, you would have the blue rectangle now without the purple region. The problem is, though, it needs to be moved down because by default, if you just chop off the top, you just change the height, it's going to scale like this. It's going to scale like this with equal amounts on both sides. So though the purple region was maybe twice the amount that you're seeing, it would have covered acne scars and fat and much more than that. When you say, I want you to become skinnier, it cuts a little off the top, it cuts a little off the bottom.
So it gets smaller like this. Okay, that way it can retain its position. The problem is we don't want to just retain the position, we want it to move down. So that's essentially what we're doing. We're getting a little off the top, a little off the bottom, and then moving it down. Okay, so chop off the amount we are above bounds and then shift it down by half of that. So we figure out how much we are above. We then scale it. We take the new height, and it is by the new height that we shift down half of it. I found that new height was a little easier to use for reference here than how much above. For some reason, I went with new height instead. I can't remember exactly why that was. But probably the hardest part of this code and what I had a bug for quite a long time was this inverted scale. It's really weird and even hard to wrap my head around it now, even though I've been working with it for a while. But the idea basically here is we need to be able to, I think of it kind of like there's like when I'm translating between coordinate systems, between a position and a scale, it's kind of like these different coordinate systems I like to think of it as. And what I need to do is get it from position to scale, from position space to scale space. And so the way that I do that is by figuring out what the inverted scale is. So if the idea here would be if your scale is 0.7, then that's kind of like an inverted scale of 0.3, meaning that that is how far you are away from 1. Okay, so that's the idea. So basically, that's what I call the inverted scale. That's just a concept I made up. And I also have to do it, but instead of 0.7 going to 0.3, 0.7 goes to 1.3. And that's because I believe it's just kind of like, well, frankly, I can't remember exactly, but it's 2.0 minus that lossy scale. And that was what I was able to finally figure out and to finally get the equation to work out. You take the inverted scale here and you multiply that by how much above, which is going to get you the sort of the unscaled, sorry, it's the scaled amount, how much it is above. And what this is determining is, okay, if it's sort of like this, it's like if I am 5 feet tall and I need to be 1 foot tall, I know that I need to be 4 feet less tall, right? You figure out how much you need to be less. But if I also told you you're 5 feet tall, but you're currently double the height you should be, meaning that there's a scale and there's a height at the same time, again, it's that little mind fuck, then you have to also figure out, okay, I know I need to be 4 feet less tall, but hey, you know what? I'm also going to be 2 times the amount. So I need to somehow get down to only 2 feet is the difference. So that's the mental gymnastics you have to go through, and it took me a long time, and I cried a lot. But this is the answer that I came up with, and it works perfectly after much testing. So what you have to do is you have to figure out how many feet, right? How much you need to change. You need to scale that, so you get into like the scalar coordinates, and then you need to subtract that by the current size. And if you subtract the current scaling minus the scaling that you need to have the difference of, you'll get to the scaling you need to be. So that's my explanation. I'm sorry if it's not sufficient. I'd love to go into greater detail and explaining it, but hopefully, if that none of that makes sense, you could use the code and hopefully learn something by playing around with it. Because I think ultimately a lot of these formulas, you do need to play around with them a little bit to get a feel for how they're working and get an idea for what I mean by moving from scalar space to position space. But that's what worked for me. And then, long story short, figuring out the new height, I just manually calculate, okay, what's my height times my scale, and then that's how much I move down by half that amount, half height. All right, so that's the crazy hellhole that I had to go through to get the bounds scaled. But once I've done that, oh boy, it's smooth sailing from here with one exception. Smooth sailing with one exception. So let's go to where we were calling that method. Fantastic. So we're going to now go in and take and save the screenshot. So we went through most of the mental gymnastics to figure out our blue rectangle. At the end of that, to figure out our green rectangle. At the end of that crazy insanity, we finally have our green rectangle, and we can proceed to finally taking and saving our screenshot. So let's do it. So this is a coroutine. Why is that? Because it takes some time to save the screenshot. And what we want to do is create a, what is this? We're going to get a rect from the rect transform, scale it to make sure that we are respecting the scale. Remember, we did this for the clone, but we haven't done it for the actual thing yet. So that's what we're going to do at this point. We're then going to, or sorry, we might have passed in the clone here. Yeah, sorry, we're passing in the clone. So here, this may be redundant, just another scaling here. No, it's not. All right, I'm not sure exactly why I scaled it twice, but it seems like I would have scaled it twice. I'm not sure. But what you have to do basically is get the rect scaled so that you have not only the rectangle at the correct dimensions, but also ensuring that it's the absolute values of those dimensions. You cannot take a screenshot of negative dimensions or you get a lot of errors. And so you could tell I have a lot of like absolute values riddled in this code base because I must have been plagued by some errors related to that. So you absolute value it and you make sure that your width is kosher. Finally, all you need to do is create a texture of those dimensions. And, oh, sorry, there's one last step. Okay, and this is actually pretty gruesome. I have to convert the rect transform to screen space. And I don't know if this is a Unity provided method, but I think I had to code this myself, or maybe with the help of Stack Overflow. But just looking at this method, you could tell it's a lot of pain. We're doing something very similar here, where we have to scale. We have to like translate size. And so what we're doing here is we're grabbing the size of the rect that has been passed in here by this rect transform. We are going to move it slightly by the scaled difference that we need. So if we need to move it by x, we actually need to move it by size of x times x. So we're getting it into the right position. Then what we're going to do is multiply it by sort of the inverted scale again. Again, you're seeing this sort of 1 minus or 2 minus the actual scale times the size here. Or here's the opposite. It's the y, then times the size. And the result is we have this rect, and then again, we're just affirming that the height is absolute value. Again, probably too many absolute values there, but I guess, it doesn't hurt to be safe. Finally, what we have is the projection rect. And it's from the projection rect that we have a screen space version of the rectangle. So just to understand what that means is basically we have the green rectangle, but it's being represented in a different how would I explain this? It's in a different space than the screen space, and we can only render pixels from the screen space. So we need to translate that rectangle to figure out where it is on the screen. And now here we kind of pretended like the game space is the same as the screen space, but in reality, the player is only going to see what's in the. Let's make this no fill again. The player is only seeing what's in this rectangle, right? They only see what's in the purple rectangle. They don't see stuff that extends beyond the screen. And so it's a different set of I don't know if it's a different set of axes, but you could definitely say it's a different set of coordinates. And so what you need to do is you need to translate this green rectangle from those coordinates that considered everything in the game world, considering things that even the player can't see, and translate it to just pixels that are being projected onto the screen. So we need to change this green rectangle. We need to change this green rectangle into a light blue rectangle. Can you see that? That's not too clear. How about pink? Yeah, it's okay. So a pink rectangle, which should be in exactly the same space, in exactly the same location. It looks like it's the same location, but it's in a different space. The coordinates have slightly changed. And so those coordinates are the ones that we can read the pixels from. Yes, so as you can imagine, this is a lot more complicated than the simple method of just taking the screenshot. But I wanted to go through it. I know. We're almost at the end, folks. It's a trick. But here we are, rendering the pixels to our to our texture here. So what we're going to do is we're going to create a texture 2D. We're going to read all the pixels from the texture. Or sorry, we're reading pixels to the texture from the region that is defined by the projection rectangle. So in other words, and this diagram is becoming very helpful. In other words, what we're doing here is we've just created a texture 2D text, okay? This texture 2D that I've created right here, let's plop it down right here. And what we're going to do right now in text.readPixels is it's saying, hey man, get me everything that's in the pink rectangle, copy it, and paste it into my gray rectangle. And the dimensions should be the same, but I'm just scaling it a little bit right here. Okay, so basically it's copying that data. That is what's happening in read pixels. And then what we're going to do is we're going to save the screenshot. So now we're just going to save this guy over here. We're going to save this to the user's device. And that is also a homebrew method, which I'll show you now, which uses, it creates this variable called bytes, which is a byte array using texture.encode to PNG. And I think this is just one of the ones that Unity provides out of the box. However, doing my research, I realized that PNG maybe wasn't the best format. So I have a to-do statement here, which is saying that there's a big saving doesn't seem to be the issue. It's just writing out bytes. But when you're loading in the image, there's apparently a big thunk with respect to memory decoding of a PNG or JPG texture. So the idea here is that it takes a little bit long to read this image format, and it might be more efficient if I use an image format like DDS or PVR, or maybe there's even a way to store it by binary. But I haven't realized a big performance hassle, a big performance hurdle, so I never switched it. So it's still just PNG. And of course, there's a lot of places in the code where it's like, oh man, I'd love to go back and like improve it and stuff, but running the entire tech stack for this whole company, right? It's like there's always a moving thing. So unfortunately, I can never get this code to a state that like I'm 100% proud of it. I just have to keep moving it, you know, as new problems come up and new features and requests like that arise. All right, enough excuses, Matthew. The point is we're saving in PNGs. And what we're going to do is we're going to create a file by opening up this destination we specify with the file mode create. So basically what we're saying is, hey, I want this thing. The operating system says, hey, this thing doesn't exist. So we say, forget it. Just create that thing. So that's what we're doing here. We're creating that file. And the path that I'm using here is, again, I think it's some sort of dynamic path. It's savedata.save data directory. This is custom. So we could go in here. Let's see what's going on. Okay, so it's application.persistent data path, and then there's some sort of NSA save data appended to that. So something like this. So this is the save data files. So we're saving it somewhere close to where we're saving the user progress, that kind of stuff. And all we have to do is create a binary writer, which is going to write each of those bytes into the PNG. And so since it's saved as a native PNG, you could, in theory, just go on your phone and open up these photos if you wanted to see them, which would not be possible if it was a binary file. But we're not doing it, so it's not really that helpful anyway. But the point is you saved the screenshot, and that's all we needed to do. So you saved the screenshot. Big whoop. Now what you're going to do is create a callback, which is the callback we passed in way back when, with the path that we saved. So let's go back to that callback just so we can complete the loop here. So we go into that callback with the file path. If it's null, then we had some sort of issue, so we're just going to fade and go home, as well as logging that error. And then the last thing, or the other option would be that it's not null. And if it's not null, then what we can do is inspect the evidence. And after all that work, after all that crazy stuff, we have this awesome result, which is that if we take this photo, it's only going to capture what we want to. So in this case, where it's saying like fat thighs and stuff, if I go to capture this note, it's scrolling it down here. it's only capturing in the bounds of that current note, and then it's saving it to file, which is exactly what we want. And it's been working really well on the devices, and it's not giving me bugs, which I had earlier. So I'm really happy about that, and I'm really proud of how it came out. And so this is also what's used in browser history, if it's partially occluded by the header there and stuff like that. It just works. Yeah, but it didn't for a long ass time. So I'm happy to have gotten it to this state. So there it is. There's the code. There's my crazy brain dump of the logic and thinking that went into this design. It's one of many tech stacks that exist in NSA that I'd love to share and explore further. But if you stuck around to the end, man, hey, thanks for listening to this crazy jargon. It's been a trip, but when you're working on something you love, right, it's a pleasure to go back to it and like refine it and fix all these little bugs so that it can become truly perfect. I have to say that upon reflection of my work on No Stranger, this is my earlier app. It's this game I built that for the longest time had some bug. Somewhere in the data there was a node which wasn't linked. Probably Scott's fault, but just kidding. Probably Tony Cucaluzzi's fault for making Dialogger in such a way that you can't tell if nodes aren't wired. But unfortunately, we had so much shit going on in Dialogger, it was hard to see where nodes were wired, where they weren't. Some node wasn't wired, and it was causing a hell of a lot of issues. And hey, what's the result? People were having a game where it wasn't saving their progress correctly. Or rather, it was saving their progress correctly, but it wasn't catching them up to the point they needed to be. And man, we had this bug plague our game for at least a year. And it's just due to a tech stack that wasn't engineered, I think, in the way that we used it. We needed something of our own. And as you grow as an engineer, or at least in my experience, as I grew as an engineer, I became more confident with the technologies I was using, and I realized in ways in which, hey, you know what? Maybe I'm fitting a rectangle into a square, or I'm fitting a sphere into a cube hole, right? It's not fitting. What if I were to create my own technologies, right? And so as I grow to mature as an engineer, I could start to roll my own tech stack, and I can find ways in which, okay, maybe the out-of-the-box method's not going to work here, so I could pursue my own path. And then, hey, maybe there's a bug here, right? So I can iterate on it. And I feel like that's one of the most rewarding things about engineering is that I can refine this method again and again and again until a state that, like, it's super pristine. It's really strong, and like I don't necessarily even think this screen capture code is at that stage yet, but you improve on it, you get better and better, and then at the end you have a product which you're really proud of, right? And to go back to No Stranger, as I did just a few months ago, and fix up this loading pipeline. I'm going to be going back to it this weekend and fixing up another loading pipeline. It's a refreshing thing, and it's a nice break from my day-to-day, which is, obviously I do this as a passion project, and it's just a really rewarding feeling to slowly iterate on it. So this is how far I've come with the screen capture software. I'm excited to see what you think. If you use it, let me know. Let me know if you improve it. I'd love to hear. And above all else, thanks for listening. I appreciate it. That's all. I'll see you in the next one.